Determine the pressure in kilopascals if 9.488 moles of gas is in a 41,670 milliliter container at 333.4 degrees Celsius. This is an ideal gas law problem, so we're going to go ahead and use the ideal gas law. I like to go ahead and customize my R, so it ends up looking like this. P₁V₁n₂T₂ equals P₂V₂ n₁T₁. This is a linear equation, and it'll make it easy to solve for pressure, volume, number of moles, or temperature. This particular one is solving for pressure. So remember, R is a second set of conditions that normally comes from our mole bridge, where we say that there are 22.4 liters for every 1 mole at STP. We're going to solve for pressure. Pressure 1 will equal n₁T₁ divided by V₁. Additionally, R will be put off to the side on the right. So on top, P₂V₂, on bottom, n₂T₂. The n, the t, and the v all cancel out unit-wise. If they don't, I can use a conversion to do so. We'll solve for pressure. We'll go ahead and put everything in place. Our moles, our temperature converted to Kelvin because that's the only way to use it, so add 273.15 to your Celsius temperature. We'll also put our volume on bottom. Now we can go ahead and inspect our units, because when we customize our R value, we want to make sure all the units that we have cancel and the unit that we desire can show up. Remember, for every 1 mole, we'd have 22.4 liters of space occupied at standard temperature and pressure. Standard temperature is 0 degrees Celsius or 273.15 Kelvin. Standard pressure is 1 atmosphere or equivalent, which would be 101.325 kilopascals. I can't use liters. Notice I need milliliters to cancel. So either I need to go ahead and adjust this to 22,400 milliliters or put in a conversion to make milliliters and liters both cancel out. After which, I'll go ahead and multiply across the top, divide by the product of the bottom, and get 1,147.57 kilopascals. If we're looking for significant digits, my answer should only have 4, which would make this 1,148 kilopascals.